Hey, hello. Thanks for being here. We're going to try to answer as many of these questions. So, when you register, we invite you to send in a question. And of course, you can send a question anytime. We kind of look these over and kind of group them. And a lot of times we'll sort of get the same question asked two or three different ways. So, if it doesn't look exactly like your question, that's why. Um, so I thought I'd start with an easy one. I got a bunch of questions about FCC Part 74 license. A Part 74 license is the license that you use for wireless microphones. Since 2013, they are no longer required if you stay under 50 milliwatts, which is pretty much the standard of what you can buy. If you're a broadcaster or something, you can get a license that allows you to use up to 250 milliwatts. For normal wireless microphone use on a stage in a church and a club, uh, there's almost no reason to ever do that. Uh, there's some bands and stuff that you need a license for. The up in the 950s, you need a license that's used by satellite transmission link. That's broadcaster stuff. It's kind of like if you have to ask, you shouldn't be there. That's for full-on pros, and it's very heavily regulated. So the funny thing is, to get a license, it's advantageous to have a license. It's not expensive, but you have to have 50 devices at your premises. That could be mics, ears, comms, but you have to have 50 radios to get a license. So that leaves most of us out right away. Anyway, question, why did they sell the 600s and not someplace else? Well, there isn't any place else. I mean, they would have had to taken over something, give up something else to get that. What they did was they gave up the above actually above 6, 14, 15, 16, I don't know exactly where it cuts off. They gave that up for the higher television stations above starting at channel 38. And the reason they gave that up is the government got $50 billion for that. That's why they didn't pick someplace else. Also, it's a very good place to be. T-Mobile, by moving their cell phones into the 600s, now have towers that will broadcast for 40 miles. It's big improvement. So they can shut down a lot of towers, save them a lot of money. That $50 billion, part of that's back in your pocket. You probably don't realize it. For the last, I don't know, 7 or 8 or 10 years, they're actually withholding less from your paycheck every week, and that $50 billion is paying for part of that. So it's actually in your pocket. Probably don't know that. And the other question I got was, what do I do with my now non-legal microphones? Well, you turn them off. It's illegal to use them. You can't sell them in the United States. That's illegal. You can't repair them in the United States. That's illegal. Now, if you send your microphone back to Shure, Sennheiser, Audio-Technica, they cannot repair it for you by law. So really, about the only thing that you can do is sell it or donate it, outside the United States. I see people trying to sell microphones to Africa, for basically nothing. So, yeah, they're bookends now. They're paperweights. You cannot use them. You should not use them. And yeah, that's the end of that. There were some rebates. I mean, all these rules changed about 5 years ago. So, this isn't something real new. But anyway, it just is what it is. You really should be, if you're using wireless microphones, and you're not a full-on pro with a lab full of gear, you should be using them in the United States from 470 to 608. There's some other things that are legal, but you need a really good reason to be there. If you don't have one and you don't know of that reason, you just shouldn't be there. You should just stay in the band that everything is available and everybody uses, because everybody uses it because it works. Okay, I got a bunch of questions about using wireless mics and in-ears together with respect to the antennas. Where do I put them? How do I aim them? And of course, the number one rule with antenna always is you point the antenna at the transmitter, right? Just like it was a cardioid microphone, you point it at the singer. You don't point it the other way. So you have to point it at where your transmitters are going to be, which is usually in one place. Sometimes that's challenging, but you do that. So basically what you want to do, if you have a room, we'll just pick a rectangle. So you might have to modify this depending on what you've got. But you know, if you want to put them on the back wall, you put your wireless mic antenna and your in-ear monitor antenna about 6, maybe 10 feet apart on the back wall, and you point it towards the stage. That's a good way to do it. You also could put them both in the wing of a stage, either side. I just showed it on one. It could be on the other. It wouldn't make any difference. Again, you want to put those antennas about 6 feet apart. The reason we split antennas is because as they're working, they're actually generating magnetism. They become electromagnets, very weak, but that magnetism jumps from antenna to antenna and causes noise. So if you split them about 6 feet, that's about 3 wavelengths. You almost completely eliminate that. Okay. The other thing you can do is you could use them at 90-degree angles. It's better the other way, but this is acceptable. So you could put one on a wing and one on a back wall or whatever, 90 degrees apart. This will work. The thing that you can't do is this. You can't point one at the other. In many ways, this would be like having a microphone and pointing it at a speaker. You're going to get feedback. Well, you don't get feedback, but you have other bad stuff happen. So you just don't want to point them at each other. This is the thing you need to avoid. This will cause you nothing but problems. So just about any other way is acceptable except for this. Okay. I got questions about, you know, why do I get noise, other disturbances in my in-ear monitors? So in-ear monitors are almost all single-ended. They're not diversity. And the reason for that is they've got to build a small belt pack that runs on a battery for a long time. It's got to be small, it's got to be lightweight, and it's got to last on a battery. And that's just more difficult than when you can power it off the wall. So there's only one receiver in almost all in-ear monitors. And you don't have diversity. So you don't have a second antenna to jump to if the first antenna starts becoming bad or poor or whatever. So basically, there's 2 kinds of antennas that you'll normally run into. Linear antennas, which would be your whips or paddles, and circular polarized antennas. There's a third, elliptical, which is just a bent circle, so it behaves the same way. So what happens when you have a linear antenna is that it wants to be in the same plane that your receiving antenna is, right? So if they're all vertical, they're all horizontal, they're all 45 degrees, it doesn't matter. As long as they're the same, you get maximum transfer. A circular polarized antenna down on the bottom there is spinning the output at 360 degrees at the speed of light. So it's slow here, but you can't be in between a part of the circle. So it doesn't matter how you turn. So what happens as you're just normally on stage with your belt pack, you're going to be moving. You're going to be twisting and bending. If you get to 45 degrees, you'll lose 3 dB of signal. You get half power. That's not usually a problem for anybody. But as you twist more, if you actually were to lay down flat on your back, for example, and your antenna was vertical, you'd probably be picking up less than 1% of what it's transmitting. Now, probably don't spend a whole lot of time flat on your back unless you do a lot of crowd surfing. But what's happening is your signal level is constantly going up and down. And with analog wireless mics, and wireless ears in this case, analog radios are the signal quality, the sonic quality is directly related to the antenna signal quality. With digital, it doesn't matter so much because you're sending codes. You're essentially sending ones and zeros, and they're always ones and zeros until it just doesn't work anymore. But with analog, every time your signal's a little weaker, you're changing frequency response, you're changing dynamic range, you're just changing the sonic quality of the mic. So what's happening is you're moving around on stage. Even if you don't drop out, the quality of the sound is constantly changing. And so by using a circular polarized antenna, you eliminate that possibility, because no matter how you turn, it never changes, right? So if you're just using a whip antenna or a paddle antenna is stronger, which is not necessarily a good thing, but sometimes it is. But if you change direction, its quality goes up and down. So if we could fix the receiver, if we nailed it down so that it was always vertical, you'd have no loss. But then what would be the point of having a belt pack? You're going to move. So as things bend and twist, the signal quality is constantly changing. So what you really want to do, the biggest improvement you can do to an in-ear monitor system is to switch to a circular polarized antenna. Of course, you have to have a combiner to do that, unless you want to buy one for every transmitter, which would become very expensive. But you could do that too, I guess, if that's what you wanted. Anyway, a circular polarized antenna will take care of almost all of that. And that, so if it's the quality, you're not really getting dropouts, you're just getting noise and birdies and garbage. Switching to a circular polarized antenna should just about 99.5% fix that. Okay, I got questions about bandpass filters and how to pick the correct bandpass filter. So I think probably a lot of you have seen this this scan that I did. So we can use wireless mics. Again, I'm talking in the United States. It's a little different in other parts of the world if you happen to be there, but we can use 470 to 608. So that's right above the green. There's interference from video walls, video monitors at the low end, and from cell phone, 5G T-Mobile cell phones at the top. If you add a bandpass filter, you can see how much you clean up the signal, especially from about right here and up. So, I mean, just look at all the garbage we've taken out. That's the single easiest thing you can do to improve a system. But how do you know which one to use? Well, we make 5, actually 6. For anybody that's outside the United States, we also have a new 470 to 698 filter. So if you're in Europe or other places that use that frequency, we've always had the 4 units, but we've just introduced a bandpass filter that covers everything in the United States. So you can use this one without having to worry what frequency your mics are. The other filters, well, all the filters, they have a number. So you got to be able to tune your mic in between the low number and the high number. That's all you've ever had to do. Sometimes you can't do that because you've got different blocks and they're all over the place and they don't fit inside one filter. There's ways around that, but they're very expensive and complicated. So we've come up with this new one-size-fits-all filter. So you can order this one, you can keep it in stock. You don't have to worry about what channels you might be switching to. That's a problem for touring people, right? You get off the bus and you may have to tune to different frequencies that now your filters don't work in. So this new filter, 470 to 608, I think we're shipping these now. You can order them now. Last I checked, all we were waiting for was the label. So these go out the door any day. It just makes it easy. You don't have to think about it anymore. The other ones have some uses. If you can use the narrower ones, they're better in some circumstances. In some circumstances, it wouldn't make any difference. The difference between the two is extremely small anyway, so it's not like you're losing out a lot if you got the wrong one. So this is just an easy way to do it now. You don't have to think. Just get the green one. It works with everything. Remember, we're using these bandpass filters on receivers. So we're using these with wireless mics. There's really no need to use them on in-ear monitors because you're only transmitting a single signal anyway, right? With a wireless microphone, when you stick an antenna up, you are picking up every radio in the entire world is going into that antenna, and your receiver has to try to figure out which one you want. So blocking some of that that's coming in to the antenna makes the receiver's job that much easier. And you saw from the scan that we ran there, the interference from new stuff that we just didn't used to have. So it's much harder to do wireless microphones now than it used to be. And these filters just are probably going to improve your dynamic range by 4 to 6 dB. So remember, I'm always talking about you got to maintain 20 dB. So whatever you've got, you'll make it 4 to 6 dB better right away. That's a pretty big improvement for not much work. So anyway, with this new one, 470 to 608, you're covered for anything in the United States. And there's a 470 to 698 that works in most places in the rest of the world. Okay. So moving on. Well, this is a great question, and it has 1,000 different answers, but let's see if we can kind of get you thinking in the right direction, right? So if you get dropouts, so first of all, we're going to say we're not considering broken gear, right? So if you've got dead batteries or you dropped the mic and smashed it, okay, well, that's easy to figure out. But in an otherwise working system, what happens to get a dropout, what's happening is you're not maintaining that 20 dB of dynamic range, and then your mics will drop out. So there's basically two paths you want to look at if you're having dropouts. You want to know, is everything dropping out or just some of the mics dropping out? If everything's dropping out, then you're either out of range, you're too far away, or you probably have something in the antenna system that's not correct. So you could have a broken antenna. That's pretty hard to do, but you could have a broken antenna. You could have a cable that's not completely plugged in and you're losing signal, or somebody stepped on the cable, or somebody bent it at a 90-degree angle or something like that. Your cable's failed. Your distro could be failing. If the power supply were to go out, it would take out all the channels at the same time. So if everything's going out, you're probably looking at some kind of a hardware problem. And then you just have to go down the list of all the possibilities that there could be. You want to start at the back end, right? So when we troubleshoot, we start at the back end. We start at the receiver, so we undo everything, stick rabbit ears in the receiver, get your mic out and see if it works, all right? If it doesn't work, then your receiver's dead, but your chances of having all 4, 8, or 64 of your receivers going bad at the same time is not very likely. It's likely something in front of that, but you got to prove that receiver's working. If some of your channels drop out, but other channels stay on, then you're pretty well assured that your hardware is okay. And at this point, your problem's probably your frequency coordination. Right. So as you turn on more and more what you can do. So let's say I've got 8 microphones, and let's say 2 of them I'm having problems. Well, there's 6, it doesn't matter. But some of them are working. So an easy way to prove your receivers, so if you've got one channel that's working, tune all 8 receivers to that frequency, turn off all the rest of the transmitters, and then all 8 of your receivers should be receiving that one good channel, right? That pretty well proves your hardware out. Now, as you start to turn on other channels and you start to get dropouts, what's happening is you're getting intermodulation. You're getting interference between the transmitters. All radios interfere with other radios. It depends how close they're tuned in frequency. It depends how powerful they are. And it depends how close you're physically standing to each other. Okay. So all those things come into play. But if you're just having trouble with, 1 or 2, like I said, if you tune them all to one channel, you can prove that your equipment's working. And now if it's not working, you probably need a better frequency coordination. And we have a really good tool on our website that's free to use. You just go to our website, rfvenue.com. Up on the top, there's performance tools button. There's a big round button. Click on that and go to the wireless system builder. There's a performance tool and a system tool. Go to the system tool, tell it where you are, tell it what microphones you have, or what in-ear monitors you have, what brand, what block, and all that, and it will do a frequency coordination for you. It'll work a whole lot better than the auto scan things in these radios. That used to work really well, and it just most times, most places is not really great. It still works some. It could work perfect. It may not work at all. But this is it's a web app. You can do this with your phone when you're there at the venue, and it's going to give you the frequencies. You can do better if you stick a scan into it. If you have a scanner, and you can import that data into it, it'll do even better. But it'll do a great job, provided there's nothing unexpected in that room. So, for example, if you had an X-ray machine on your stage, or you were in the middle of a military airfield, it's not going to work too good. But I haven't done much of that lately, so it's not very likely that's going to pop up for you. So that would be a way to get a frequency coordination. But I can tell you that most of the phone calls that I get for people that are having problems are caused because their frequency coordination is the culprit. And a bad frequency coordination, causes that dynamic range to drop below 20. That's what makes your mics drop out. So just switching the channels is a good way to take care of that. What else do we got? Do RF Venue products work with all brands? So the quick answer is yes. Think about what we're doing here. So there's two parts about making a wireless microphone work. One part is you've got to move the radio wave, the electromagnetic signal, from the transmitter to the receiver. That's what we do at RF Venue, right? There's other stuff that's happening, about how the radio actually operates, but you've got to be able to get the signal from the transmitter cleanly to the receiver. Okay, so that's an electromagnetic wave. We all use the same electromagnetic waves, right? So you can use a Shure antenna with an RF Venue distro into a Sennheiser digital wireless mic and an analog Audio-Technica mic all at the same time, as long as you're in the right frequency range. So I try to come up with an analogy, and analogies usually are stupid, but it's kind of like putting gasoline in your car. Your car doesn't really care what gas station you go to, provided the gas has the proper octane. So it's the same thing for the radio signal, provided the radio signal is the frequency of the gear you're using, right? That you can't tune Wi-Fi into a wireless mic antenna. But if the frequencies are right, it really doesn't matter what brand of gasoline you put in your car, provided the octane is the right number, right? In fact, I'm told, the same tanker truck is delivering gas to Shell and Chevron and Exxon all at the same time. So you're probably getting the same gas anyway. So it's the same way with the radio waves. There's no proprietary radio waves. We're all using electromagnetic waves. They're a force of nature. They behave the way they do in everybody's brand. So you can't take a Shure transmitter and expect it to work with a Sennheiser receiver, but you can expect the radio wave that's coming out the transmitter to flow through the air, collected in the antenna, down through all the stuff, and get delivered to the receiver. So that's what we do at RF Venue. We deal with the radio waves, and that's what we do a very good job of, delivering that back to back to your receiver. So once that gets there, you should be in pretty good shape. So that is the most of the questions that I received. I got some questions about stuff that just wanted to know about working with Wi-Fi, wanting to know about working with, well, that's really outside of what we do. So I would refer you to, if you're working with some other brands of something that's something else, that you contact those manufacturers. But other than that, for anything that has to do with, wireless microphones and those frequency bands, that's what we do. So
Excellent.
that's
Thank you, sir.
kind of the ones that we got that people sent in beforehand. They tend to come in kind of in clusters. So I get 3 or 4 people ask sort of the same question. We're obviously not explaining it very well, so we'll try to do that again. So did you get some other ones there?
Unfortunately, we didn't, but now's a good time for anyone who has questions to ask, and we can answer live.
Yeah, you can put it up on either the chat or the Q&A button, and we'll get them. But so why don't you read me one you got off the paper there, sir?
All right, let's see here. Let me go to the sheet. I think you covered every single one we got, Don, actually. See if there's any other ones. Oh, yeah, you did. Disturbance.
Every single one. You guys are going to have to try harder. Stump the band.
We got to stump Dawn on the next one, guys. Come on. So, there hasn't been any questions and answers, but this is a good time to ask everybody who's still with us here how many webinars they've attended. So I'm going to go ahead and kick this poll up.
Yeah, we kind of like to know because it's basically the same information, since all the rules of electronics and physics and all that haven't changed since they built the first radio. We're stuck with this set of rules, and so there's sort of some basic things. Once you learn 5 or 6 basic things, really, you'll know the answer to 99% of the questions that could pop up. And go from
Cool.
there.
I think we completed the poll. So thank you for that, everyone. We appreciate it. And it's good to see that we've got some people who have been to many of our webinars. So that's great. I'll go ahead and share the results there. You guys can see that.
Oh, well, so half the people, this is the first time. Well, thank you for tuning in. We try to do this once a month on the last Thursday of the month.
All right, we got a question, Don.
You're welcome to send questions anytime, of course.
Absolutely. You can always email us directly. I'm just Adam@rvenue.com. And of course, Dawn is Dawn@rvenue.com. We do have one question here. Thank you for this. Is there a best practice when it's not possible to keep distance between antennas and LED walls?
Use wire. Everything is okay. So what you want to try to do, LED walls, the power supplies tend to spit out RF junk. So the best you can do is to use directional antennas and point them not at the video wall, right? So if you've got a stage and you've got a 50-foot wall behind the performers and your antenna's on the back side of the hall and you're pointed straight at the video monitor as well as the performers, you're going to pick up a lot of that video wall. So in that case, probably putting something in a wing and pointing it sideways would be helpful. This is where it's hard to guess, because it's hard. It's also hard to figure out which way the interference is going to come out of that video wall. It's not always the same way. It's not always even. So this is where you really, if you have a scanner, see, it's getting to the point where we just can't guess anymore. We're dealing with something that's invisible. We got to be able to measure it. We got to find footprints, right? And so if you do this seriously, you need to really be thinking about having a scanner, because when we see what's happening, when we can measure what's happening, then we know what we can do to avoid it. But you another thing that you might do if it works out right, you might put the antenna on the ceiling and point it down, because you could put it like directly over the video monitor and point it downstage and at the performers. That might help avoid it too. But and then of course the bandpass filters that could take care of it all by itself. In some cases it won't. Every one of these brands does something a little different, so we can't say that one thing always works.
We got some more questions here, Don, definitely in line with what you were just talking about. When you're doing your initial scan, what's a good rule of thumb for your start, stop, and center frequency markers?
So when you're doing an initial scan, so like if you're walking into an empty venue for the first time, you want to use an omnidirectional antenna on your scanner. And we recommend that you scan probably 30 to 50 megahertz on either side, above and below whatever frequencies you're considering using, right? So if you're considering using 470 to 608, just add somewhere between 30 and 50 to each one of those numbers, right? So 420 to 650. You want to scan those because things above and below the frequencies you can use are affecting you, and you need to know what they are. If you scan with a receiver, into Wireless Workbench or some of the other programs, you can only see what the receiver sees. So when it's calculating where you should be, it thinks it's all by itself, but it's not. So it's probably not giving you the best information you could get. Now, on the other hand, if you have a radio that only tunes from 520 to 560, I really don't need to know what's at 650, because it's not going to go that far. So again, I'm going to add 30 to 50 to each one of those numbers, whatever I said, and that's where I want to scan. Now, when your system's actually there and running, now you don't want to use the omnidirectional antenna on your scanner. You want to actually tap into your system, because if you're using directional antennas, and you almost always should be, I don't care what the interference is on the side that my antenna can't pick up. So I really don't need to measure that. I only need to consider what my antenna for my system, for my real microphones, can actually use. So now I want to switch to a directional antenna. I want to use one side or the other. You don't have to use the A and the B channel. It's not going to matter that much. And there, you'd have to have two systems. It gets extremely complicated for like almost no benefit. Just pick the A side, scan with that, tap off your distro, scan with that, and then again, add 30 to 50 above and below whatever you're concerned with.
Awesome. That was fantastic info, Don. Thank you. There's a good one for you. Any recommendations for when you have to operate wireless mics very close to a cell tower?
Hope you're inside a building. So what's happening is, you can't move the cell tower and you can't move the building. Bandpass filters will knock a lot of that, most all of that, 99% of that away. But 99% of something that's 1,000,000 is different than 99% of something that's 100. So as you get very close to it, that's a very powerful signal. And so even having 1% left over, if you're directly underneath it, is not going to be good. Obviously walls help. Outdoors is you have no blockage. Walls are going to cut some of the signal down. But it is what it is. That's the best you can do. The bandpass filters is the obvious, easy choice. And, keep a couple of those in your toolbox and, drop that in, and that probably is going to help you. But any interference, it's directly proportional to distance. So the farther you can get away from it, the interference will become weaker and weaker. But, there's can't move that tower. So you can filter it down is about the only thing you really have available. And then if that's not enough, Then what you have to do is you have to move your frequencies as far away from that, whatever frequency that is. So if it's a T-Mobile cell tower, it's 617. So you want to be at the low, you know, if you can tune your mics at 470, 480, 490, 500, I should say that's called T-band. And that's a problem in metro areas because there's potentially some emergency stuff that could come on there. But unless there's a disaster, that's not going to come on. So, and if you're in the middle of a hurricane, you probably have bigger problems than mics dropping out.
Indeed. Well, that's all the questions we've got. I don't see any more coming in, but again, you can always email us directly. We're happy to take a look at any of your questions. But thanks again for joining this webinar. We always appreciate your time and efforts. And anything else, Dawn?
No. Take a look. We have an awful lot of stuff online on our YouTube channel. You can get to it from our website. You can search in YouTube. We have lots and lots and lots of educational stuff. You probably know most of it, but you probably could find a few topics that maybe you hadn't thought about. You might want to take a look at those. And then if you have problems with those, send us an email. We'd be happy to explain further.
Excellent. Well, thanks, everyone. Have a great rest of your day and enjoy the upcoming weekend. Take care.
Thanks, guys.
See ya.